Okay, well, this problem we're going to be trying to prove that that a set of a quadrilateral made out of the given 4 points is not. Well, it is a trapezoid, but it's not an isosceles trapezoid. Okay, so here's how we're going to do it. This is actually a fairly short and simple proof, but it's more visual. Like you have to just kind of understand what the heck I'm talking about. So I'm going to share my screen and we're going to go over to Desmos. See, in this case, this is our trapezoid that we have here. Well, I mean, it's a thing that we think is a trapezoid, but we're pretty sure. And the reason why we are is because, well, we basically, B and C, which are 3, 5, and 6, 5, they're both on basically the line y is equal to 5. And the points A and D, which are 2, 2, and 8, 2, are both on the line y is equal to 2. It's y equals 2, y equals 8. Very clearly, there's never going to be a circumstance where y both equals 2 and equals 8. So these two lines that go through these points never going to meet. So let's just take an example. Y equals 2. That goes through A and D. And you have y equals 5. Was I saying 8? I'm an idiot. But it's the same general point. You have y equals 5 and y equals 2. These lines are never going to cross because, well, it's impossible for y to be two values at the same time. It just doesn't make any sense. So these lines are never going to meet. So that means that these two lines are parallel. And it's also fairly obvious that if we have a line through A and B, it's not going to be parallel to the line CD. I mean, if you just look through it, you can kind of trace it out. The line's going to kind of go like this, and it's going to meet the CD line somewhere over here. It's going to cross somewhere in this general area up here. But it's fairly obvious that, you know, their slopes aren't the same, so eventually they're going to meet. That's the only criteria you can have for non-parallel lines, that the slopes are just different. It doesn't have to be like, you know, insanely different. It could be like a difference of 0.01. But the point is it will eventually meet somewhere. And the slopes of these lines are pretty different. So they're going to meet somewhere up here. So these lines are definitely not parallel. So we have exactly one pair of parallel lines. So this is a trapezoid. What's also fairly clear is you don't have an isosceles trapezoid. Now what an isosceles trapezoid is when A, B, and C, D would be the same length. And though you would technically need to use the Pythagorean theorem to prove this, intuitively you can kind of just see it. This distance, it's only 2 to the right and actually no, how much is it? It's 1 to the right and 3 up. This is 1, 2, this is 3 to the right, or no, 2 to the right, and this is 3 up. So it's fairly clear these are going to be different lengths. I mean, you can work it out from the Pythagorean theorem. You know that since this is 2 away and 2 away on the x-axis and 3 away on the y-axis, you can work out that this side length is going to be, I think, the square root of 13, whereas this side length over here, you know, it's 1 and then 3. This is going to be a side length of square root of 10. You can work that out for yourself. So basically, this side length is going to be square root of 10. This side length is going to be square root of 13. But you can just figure that out intuitively because this is only 1 over and 3 up, whereas this is 2 over and 3 up. So it's fairly clear just intuitively that these lines are just not going to be the same length. So by definition, this cannot be an isosceles trapezoid.